I'm so tired. I'm glad I have these snacks on my table. Italian sparkling mineral water. I like mineral water because it's got compounds within compounds. It's not just H2O for the water. H2O, 2 parts hydrogen, 1 part oxygen to make water. But it also has carbon dioxide. Carbon dioxide, CO2. 1 part carbon to 2 parts oxygen. Both of those things are compounds, and they need a chemical reaction to break them apart. And typically, with water, if you wanted to break it apart, you add an electrical current. Break it up into hydrogen gas and oxygen gas, the 2 elements that make up water. This snack that I have right here kind of reminds me of a mixture. A mixture is going to be different from a compound because a mixture can be physically separated. If you look at my fruit salad right now, I can physically separate out the strawberries from the grapes, from the blackberries. They can all be pushed into individual corners and separated out, but together they make a mixture. Other things like pizza, you can separate out. In chemistry, if you want to separate things out, you'll use different techniques, such as if you know the properties of a certain element, you can use that to help you separate things out. For instance, iron is magnetic, and we can use magnets to separate out iron from different solutions that they might be in, or different mixtures that they might be in. We use other techniques like centrifuges. As a lab technician in a hospital, you might be using a centrifuge to help separate out blood. A centrifuge is a large machine that sits on a countertop, and it spins different mixtures at a high rate of speed and separates out these mixtures based on density. So blood, for example, will be separated into 4 categories: platelets, red blood cells, white blood cells, and plasma. And it's not the plasma that you're thinking of. It's the fluid matrix that all of these cells kind of float in. Other techniques, we use evaporation, and it's called distillation. And distillation is a fancy word for evaporation. We use different tubes, different glassware pieces to actually trap that gas that we evaporate. So let's say we had a sugar and water mixture. The sugar is just hiding behind the water molecules. So a sugar-water mixture could be heated, and we can evaporate out that water. It's called distillation because I'm going to trap that vapor, that water vapor, and I'm going to trap it and put it in a separate container. That's called distillation. Another technique that we can use to separate out mixtures is filtration. If we use filter paper, like you've seen your parents use coffee filters with their coffee pot, basically you put the coffee grounds in the coffee filter, hot water goes through that, and then flavored water kind of trickles through the filter paper. Filter paper could come in different sizes. So if I am trying to separate out sand from pebbles, I can use a sifter that has different size openings that will trap the pebbles but let the sand through. Those are ways that you can separate out mixtures.
All right, so we have 3 main categories of mixtures, solutions, suspensions, and colloids. The first category that we're going to talk about is solutions. And solutions contain a solute and a solvent. And this is what's dissolved, and the solvent is what's being dissolved. And I always like to say the solute gets poured into the solvent. We know that these exist because solutions dissolve. We can dissolve things when we're talking about solutions. One thing dissolves into another, and it kind of just hides. Things are homogeneous, which means evenly distributed. So if I take a sample from the top and I take a sample from the bottom, it's going to be evenly distributed. That trapped sample that I have has the same amount of solute and solvent distributed. Things are soluble, which means that it dissolved, which kind of means it disappeared. It's still there, though, because if I evaporated out the water, let's say, I will get the solute that I put into that solvent. So it just dissolved, it kind of hid, and we can still obtain it. It does not scatter light. If I took a laser and I shined it through any kind of sample that I had, it will not scatter that light. That beam of particles, if I had my sample, if if I have my sample and I shine that beam of light, it's going to go straight through. So that beam of light is going to go straight through. It won't get scattered. It'll go straight through because the particles are small. Particles are small, so the beam of light will go straight through. It also cannot be filtered. That means if I took that beaker of a solution and I tried to trap it in a funnel of some sorts, it'll go straight through that funnel, and I can't trap it. Some examples of a solution would be sugar and water, salt and water, anything that completely dissolves, lemonade, iced tea, things like of that nature. We'll try to brainstorm more in class.
Okay, so first we're going to show you an example of a solution. So a solution is when you put a solute, like the salt, in a solvent, which is like the water. And water is a universal solvent, meaning it can dissolve a lot of things. Stir it up. So we know this is a solution because she's going to stir it up and it's going to look like the salt disappears. It's going to be evenly distributed, so it's going to be a homogeneous solution. Homogeneous meaning I can take a sample from the bottom and I can take a sample from the top, and the samples will be equally distributed of salt to water. It looks like you have a chemical reaction happening, but really the salt is just hiding behind the water molecules. And the way that I know that this is just a mixture is because it's just a physical change. I can evaporate out the water and I can get the salt back.
Another category of mixtures is called suspensions. Now, what's different about suspensions versus solutions is that you don't have a solute or a solvent. Nothing is dissolved. Nothing is dissolved. You have a heterogeneous suspension, meaning you have two layers and it's not evenly distributed. It's not soluble, so cannot be dissolved. It could scatter light. For instance, if I had a sample, my particles are a lot larger. Notice that's on my list as well. So since my particles are a lot larger and I send that beam of light through, what happens is it gets scattered, and then it's going to be a little bit scattered when it comes out. I'll show you an example in class. You don't get that straight beam of light coming through. You're going to get kind of a hazy light that comes through because the beam has been scattered, and that's due to these large particles. You can also take that suspension with those large particles, and if you try to filter it, again, you will end up trapping it. You will trap it. It will not go through. So that's a big X right there. It will not go through. It can be filtered. So some examples would be sand and water, flour and water, things that are large, things that don't dissolve. A snow globe is a suspension. All these things can be a suspension.
Okay, in these next two suspensions, go ahead and add your. We don't have a solute and a solvent, and here's the reason why. A solute dissolves into a solvent, and in these two cases, you're going to notice when they stir it, you're going to notice that these two things that have been added to the water are not going to disappear. They're not going to be evenly distributed like in the other examples that we had. In this example, the sand and water, this is a suspension because it's not dissolving. It's not homogeneous, it's heterogeneous, meaning if I take a sample from the bottom and I take a sample from the top, the bottom sample is going to be sandier than the top sample. It's going to be a little bit watery. This is a heterogeneous suspension. It's a suspension I like to think of because I like to think of cutting off your suspenders that are holding up your pants and it falls to the bottom. Notice that she can stir and she can bring the sand up into the water column, but as soon as she stops, the sand falls to the bottom. So this is a suspension. It's different than a solution because it doesn't dissolve and it's not evenly distributed. If you look at this one over here, this one with the flour and the water is also suspension. If she stops stirring, it'll take a little bit longer than the sand and water, but you'll notice that the flour will fall to the bottom and you'll get a watery top with a really thick floury bottom. So This is a suspension because it's going to separate. It's not homogeneous, it's heterogeneous, meaning if I take a sample from the bottom and the top, they'll be different. We do not have a solute and a solvent for both of these because nothing has dissolved.
The last category is colloids, and colloids are kind of a combination of a solution and a suspension. They're a combo because they do have a solute and a solvent. Remember, the solute dissolves into the solvent. They're homogeneous, kind of like a solution. So the solute and solvent are very much like solutions. Homogeneous is kind of like a solution. It can dissolve, it's soluble like a solution. But here's the only thing. It scatters light like a suspension. And that's what keeps it out of the categories of a solution. It scatters light. So remember, if I shine that beam through, the particles are medium-sized. And because they're medium-sized, right here, because they're medium-sized, it's going to scatter light. But here's the trick. You cannot filter it. So that means if I took it and I try to put it in a filter, it will go through that filter. It will go through, just like a solution. So you see, all of the check marks are kind of like a solution, except for scattering light. That's like a suspension.
Thanks for watching!